Okay, let's move on. For today's webinar, we'll be looking at measuring OEE in batch or fixed output environments. Our presenter today is Ross Kennedy. Ross is the president and founder of CTPM. He is recognised as Australasia's leading authority on total productive maintenance and CTPM's operational excellence through the TPM and Lean methodology. So let's get started. We hope you enjoy today's webinar, and I'll now pass you over to Ross.
Thanks, Craig, and welcome everyone to our webinar. And I'll just get the screen up and running, and we shall be in action. Right, we're all off to go. Right, thanks a lot for joining us. Today our topic is measuring OEE in batch and fixed output environment. The topic has come about because we see in the workplace most companies tend to have operations which are just ongoing. In other words, people come to work and they run the plant for their shift and then they go home. However, we have come across situations in recent times where people are in batch operations where they make a batch of product, and once the batch is finished, well, the crew may still be there, but they've got the rest of the time of their shift to go. Or we may have a fixed output operation where we're making output, and once we've made the required output for the day, we stop production. So that's sort of the environment I want to get into today. But before we do, I thought we'd just start very quickly with the purpose of OEE measurement, so we have that clarity amongst us all, so you know where we're starting from. Creating the right loss model for those three situations. Talk about a thing called available time versus actual runtime and how that fits into the models. Developing a high-level OEE equation or equations to suit these three manufacturing scenarios, and then a little bit on about the importance of counterbalance measures and developing those. So that's the plan for today. So if we move on, and just the first part is the purpose of OEE. OEE, like lead time, is an improvement driver, not a comparative performance measure. What we mean by that is when we talk about TPM and Lean, TPM is the equipment side of improvement, and hence OEE is the improvement driver. The Lean is very much process improvement, and you tend to use lead time as the driver for improvement. So with OEE should be calculated so that 100% correlation to good output. For example, if OEE increases by 5%, then good output should increase by 5%, or the same good output should be produced in 5% less time. So for OEE is meant to be an improvement driver and not a performance measure for comparing between sites, which some companies fall into that trap. And we wrote a paper called OEE, the most misused and abused indicator, all about that topic, and we'll talk about the availability of that paper at the end of the webinar, but that goes into detail why OEE is an improvement driver, not a comparative measure, because it is not a good thing to use between sites. So with that in mind, the model for OEE as a improvement driver has 7 losses in it, unlike some of the early Japanese models which only had 6. When Mr. Nakajima wrote his first book, he talked about the 6 big losses. We've added planned downtime because it is part of what we can improve and also does impact on our ability to produce good output. So the aim of the 7 losses is to capture all possible losses that could be improved, including such planned downtime as meal breaks, regular maintenance periods, etc. The other point there, we've got a asterisk against minor unrecorded stoppages, and that should ultimately become 0 as they become automatically recorded. And what we mean by that is a lot of companies are now going down the path of using software systems to capture OEE data live off their lines. OFS is one such example. We see a number of our clients, and they're very good. So they capture all the minor little stops will be captured with those systems. That often the trouble is that probably the reasons for them aren't, especially if operators are too busy running around trying to keep the plant running. But hence they ultimately become zero and go into the unplanned recorded downtime bucket. Just on the planned downtime, again, we come across a lot of models of OEE where one planned downtime is not included. We also come across some models where things like setup or changeover time aren't included either, which is a bit of a worry. Planned downtime, what do we mean by that? Often you'll have regular planned maintenance periods. You may have team daily review meetings or toolbox meetings. You might have planned starter shift downtime. You might have paid break downtime like lunches and morning, afternoon teas. There may be some planned end of shift downtime like cleanup, etc. Then you've got your improvement activities of when you go down the path of TPM and lean and get into work area management and operator equipment management, you need to stop the line for your operators to get involved and clean for inspect and find defects at the earliest possible time. So that's another time element. Again, this is why we always capture these losses, and it's part of the model. So I thought let's get started. We've got an audience from all over the place, from throughout Australia, New Zealand, and from overseas. In Indonesia. I would just invite you to answer one very simple question so we all get a bit of a feel for where we're coming from with OEE. Some people measure OEE including the 7 losses, so they have planned downtime in their loss. Some people exclude planned downtime or other losses. So the question is quite simply, do we include all 7 losses in our model at our site? And do we not include the 7 losses? In other words, we don't have planned downtime in there if we're unsure, or maybe we don't measure OEE at a site. So we're just getting the poll now. I think it's getting close to being finished. Just waiting for the results to come along, and bingo, we have the results. So 44% of the audience do look at the whole 7 loss model. 19 don't use the 7 loss model, and 38 don't measure OEE at all. So hopefully those who don't measure OEE will get some insight into it from today's webinar. Okay, so I mentioned earlier there's 3 manufacturing situations where OEE could be measured. Fixed time ongoing schedule, in other words a continuous operation where you're continually making product. The schedule always has something ahead of it and to keep you going. We have our fixed input, our batch driven schedule. We find this in things like pharmaceutical companies, adhesive companies, and even things like pie making or some food making processes, where they make up a batch of the product and you run the batch through. And if you get to the point where you've used up all the batches which have been made, you obviously then stop production. And you may still be crewed there until the end of the shift. So this is what we call the batch driven. And sometimes we get situations like we know one music plant where their schedule is batch driven, but it's batch driven for the week. So they will run various batches up until, and they finish on a Friday, and then they don't run the weekend. So it happens on the Friday that they will finish up the last batch, and that could be sometime before the end of the shift. The third situation we find is what we call fixed output or quantity driven schedule. This is a little bit rarer, but we find it in bakeries, especially. We're doing a lot of work with some bread manufacturers who make daily fresh. In other words, people like their bread fresh every day. So once you make the required quantity for the day, there's no point making bread that's going to be stale. So you stop production and you have a period of no production, even though people are still crewed. Newspapers are the same. People don't like buying second-hand, day-old newspapers. So again, it's fixed quantity. So each situation may require a different approach to measuring OEE, and that's really what we want to talk about today. So just in summary, those three situations: you have your fixed time where your available time is fixed, i.e. you have a crew there for 8 hours, 12 hours, 10 hours, whatever. But what goes in and what comes out is quite variable. Then you have your fixed input plant where the time that you take to finish the batch is quite variable, and how much you end up with can be variable depending on what yield losses you have in your batch. And then the third option is the time's quite variable to get to that fixed finished output that you need, and the inputs can vary depending on how much waste you have along the way. So there are three scenarios. So it's about creating the right loss model. Now, creating an equipment loss model is an important part of measuring OEE, and this is an example of a model for your fixed time ongoing schedule. So this is the model that is probably used by most sites, or could be used by most sites. It starts off with your theoretical time, in other words, whatever period you're measuring. So it could be 24 hours, it could be the shift, it could be the week. Then there will be a period, or could be a period, of no demand. In other words, we don't work the weekends, or we might only work 1 or 2 shifts a day. So there's a certain amount where we don't crew the place, and we take that out, and then we're left with our required time. Now we've added in there this one called special events. What we mean by special events are things like might be new product trials, or might be having a special maintenance shut for, say, a 2-day shut or 1-day shut, and we still have the crew on site. And like Mr. Deming taught us about statistical process control, etc., you always note the special events, and we always suggest you take them out of your ongoing OE measurement, so you're getting a proper trends on what's happening. That leaves you with your 7 losses. So our OEE simply becomes the, we put the line over there and it includes all the 7 losses, and a way of measuring that is that the value adding time at the bottom after you've taken all the losses off over the available time up the top will give you your OEE for your loss. Now, when we go into the fixed input and fixed output schedule, we add an extra line, and that extra line becomes what we call the actual runtime. And you now have another loss called no production required, because we have finished the batch and we don't need to make any more, or we've made the required quantity. So the question then becomes, does our OEE stick to the available time model, and no production required becomes a 8th loss? Or do we keep our OEE being actual runtime and we take no production required out of the OEE equation? And that's really the question we find, because what we've seen at sites is that both scenarios are used at different sites at different companies. And the question is, which is the better one to use and why? So if we think about our available time, and as OEE improves, the actual runtime in a fixed input and fixed output environment means that we will actually make our, or process our batch quicker, or make our required output quicker, so the actual no production time increases. as our actual runtime decreases. So what does that mean? Well, if no production required is included in the OEE model, then there is no incentive to improve OEE, because as you address the other 7 losses, no production required will increase and OEE will remain the same. And that's why we believe it should be taken out of the OEE equation, because it comes back to, I guess, some of our learnings about improvement and behaviours, etc. When addressing the question, do we include no production required time in the OEE equation, measures dictate behaviour, and what we're trying to do is get the right behaviour in the workplace. And the idea of continuous improvement is to get everyone to behave in a way that makes the place more productive and reduces costs. And measures will often dictate the way people behave. So if we have OEE that includes no production required, we have seen scenarios where people say, well, what's the point of rushing to get the batch fixed? Because all it means is that we have time, but our OEE doesn't change. We don't get a higher OEE because we've got this no production required time. And in fact, you can sometimes get scenarios where people will go, well, let's just drag it out, because if we have no production required time, sometimes we will be sent to a different area to do work we don't like doing. And that's another thing we've got to think about in this management of no production required. The other thing that we need to remember is if you don't measure it, you can't manage it. So it's all very well having this no production required, but it should become one of the measures that are reported, for example, at your daily review meeting, not just the OEE, but if that is a scenario for you, then no production required should have equal presence so people can monitor what it is and what's happening with it. So managing no production required during crude time. Now, obviously no production required and you've got everyone there, it's not very productive. So a bit like setup reduction. How do you reduce setup reduction time? First of all, let's eliminate it totally by having a dedicated line. So can we do something that will get rid of no production required even in a batch environment? So how do we move the plant to a fixed time ongoing schedule is a question we always ask. And that could be by moving to a 24/7, but that's always dependent on demand. It could be increasing batch sizes, and that may or may not be suitable. You then have fixed output situations. Introduce further products that don't have a daily shelf life. It should be shelf, not shelf life, sorry. For example, you're making daily fresh bread. Maybe you can make another product that might be a dough that can be frozen and reheated on a vendor site. Could be a product you could make. So you introduce a different product that allows you to keep the plant running. So things you can always look at, how can we get to an ongoing schedule situation so we don't have this problem of no production required during crude time. Alternatively, you use the time for ongoing continuous improvement activities, such as work management and operator equipment management, where we get all the operators looking at improving their equipment, improving their work area, and improving their equipment, and things like regular claim for inspections to find defects at the earliest possible time will give you significant benefits in reducing your maintenance costs and give you significant benefits in improving OEE performance. So it's really utilising that time if we measure it, manage it, and utilise it in a highly productive way for doing ongoing continuous improvement. Right, the next point we want to talk about is just the high-level OEE equations. When you calculate OEE, I was showing you what we call the time loss model, or, where we take away all the time from the losses and then take the bottom evaluating time and put it over the available time. The other way of calculating OEE, which is using equations where we get the percentage of availability times percentage rate times percentage quality, and that gives us our percentage OEE. And there are equations for working out availability, there's equations for working out rate, which involves both reduced speed and minor unrecorded stoppages, and there's a quality equation, which is often the simplest way of doing that is a mass balance approach. Now, what we find is because we're multiplying these three things together, as we learned in our days of algebra or sums at school, if we have the same item on the top of the equation and on the bottom, we can eliminate it. For example, we might have processed amount up here and processed amount down there. Now, if we take that thinking and look at all the things on the top and bottom that are repeated, you've got your actual speed, you can take out your processed amount and processed amount, and the available time and all recorded less all recorded downtime is along here, which is your reported production time. So they all come out, and you end up with a very simple equation of good output produced over available time times ideal rate, and we call that the high-level OEE equation for, in this case, the fixed time ongoing schedule plans. And we find that equation is a very simple and easy way to calculate OEE, very accurate, and should be done regularly. So hourly you can do it, so that when your line is running, if you have a problem, you identify it after an hour and you can take corrective action, not waiting for the end of the shift. You can calculate it daily or weekly and graph it and watch for trends as a outcome of your improvement activities. Now, when we move on to fixed input and fixed output scheduled plant, we have our high-level OEE equation for fixed input to complete the batch, and simply all that happens there is the available time becomes actual runtime. Our fixed output plan, it's a little bit more complex, and the equation has an extra element in it, but we're talking about ideal runtime, and we're talking a little bit about processed amount to get a more accurate figure. Again, it will give you a very accurate answer of how you're performing if you're in that scenario. The key to OEE is to have very clear definitions. I've just put in here the definitions to support the high-level equation. So what's the definition for good output? What's the definition for available time? What's the definition for actual time? Ideal speed, I won't go into that today. We have we talk about that in a lot of our training. It's in that paper about OEE, the most misused and abused indicator. It's also in an OEE booklet that we use for training everyone on, which I'll talk about shortly. We have ideal runtime and processed amount. So very important if you're doing OEE measurement that you have very clear definitions that everyone follows. And the last point for today was developing and monitoring the right counterbalance measures. So what do we mean by counterbalance measures? Well, it's all got to do with the learning that OEE by itself doesn't tell a complete story. It's a very good improvement indicator. We have OEE and we work out what our performance is. We determine what the ideal target for OEE is on a line based on all the assumptions for the losses, and it helps us close the gap. But we also have to keep an eye on other things, because OEE is about equipment performance. It doesn't cover things like productivity. We've seen situations on some lines where they've been having a lot of problems with small stoppages, issues, and they've put someone extra on the line to help out. Consequence is that the losses are addressed on the run. OEE looks good. However, the productivity of that line, which is how many people did it take to get the output, has gone down significantly. So that's an example of a counterbalance measure. Quality I've put in there, quality is part of OEE. However, it's probably the most critical part of OEE of those three elements. It's a quality element that typically costs you the most. If you have a quality loss, it means you are more than likely throwing away your raw materials. Whereas if you have a downtime loss, it means you're just not using your raw materials because you're not running the plant. Or if you have a speed loss, you're just going slow. But a quality loss is I'm throwing something away, and therefore we need to monitor quality by itself because that's a part of the OEE that you really want to address first and do something about. And the third example I'll put there is no production required during crude time. We've got to know exactly what that time is and monitor it so we can use it for our ongoing continuous improvement activities or make changes to the way we run the place so that we can minimise it. So monitoring the right counterbalance measures is critical, and that's just an example of some counterbalance measures, but you really need to take a holistic look at performance. Don't just look at OEE and talk about OEE. Has been our learning. Okay, hope you found those 5 points of interest and help on your improvement journey. Just a couple of things, how can we help? I mentioned about that OEE paper, the most misused and abused indicator. That's available in our members section of the web page for free download. I also mentioned a booklet that we have that we use in our what we call a macro-focused equipment and process improvement cross-functional team. It's the sort of team we start when we first started a site where we pick a line. We'll have a couple of teams, but each team would look at a line and do a very detailed analysis of OEE performance, looking at not only continuous recording of OEE, but also the high-level OEE and sampling of OEE. And this is a little training booklet that has a great pile of slides and information in it, which we use to train the teams on OEE. So that's available if you wish to on our online store. We also, Chris mentioned earlier about membership, and membership continues to grow. It's a great way to network with other companies and get access to latest thinking. There are members which are, I said, continually growing all the time, which is great as we develop our community. We also have on LinkedIn, for those who use LinkedIn, which is quite a common thing these days, we have a group called CI Community of Australasia. So if you go and search for CI Community of Australasia, you'll find us there. We post allows you to post questions, engage in conversations with other members of the community. That's totally free to join up on LinkedIn. Pick that as one of your groups and monitor what's going on there if you find these sort of discussions of interest. The other media we use is YouTube, and you can search for us there on CTPM Australasia. If you just put CTPM in, you get some strange thing, but CTPM Australasia will find us straight away. We'll put this webinar up on YouTube later today. All our other past webinars, and I think I'm up to about 30 now that we've done that are on YouTube, are available for you as well to have a look at. So with that, I'd like to hand over to any questions, please.
Just having a look for any questions now. If anyone has a question, just press the raise your hand button or type your questions below. It looks like we have one question here for you, Ross. The question reads, you briefly mentioned ideal speed but didn't expand on its use or importance. Could you explain what ideal speed is compared to other speeds or rates we come across in manufacturing?
Okay, thanks for that question. Yeah, different speeds found in the workplace. This is something we go into in the little workbook when we're training people on OEE. Ideal speed we define ideal speed in three ways. Either the original equipment manufacturer's design constraint speed, in other words, that's the bottleneck item will actually run at, or the critical part of the plant, I should say, the critical piece of equipment should run at, not the bottleneck, but the critical piece of equipment. For example, often it's a filler if you're on a filling line. It could be if that information isn't readily available, it's a sample speed, which is measured over a very short period, like 10 minutes, and using your best operator and best conditions, or if you can use upper control limit as the upper control limit of the speed if you've got a trend of what's happening with speed. But what we find in the workplace, there are a number of speeds that are mentioned and used, and we've got to be careful that we understand their role and what they do. For example, there's standard speed, which is often used by production planning and costing people to say, this is how we cost their product or plan to make product. We have optimum speed, which can often be the maximum you will allow a line to run due to current conditions, so it minimises quality waste, because we know our equipment may not be in perfect condition. You've got your ideal speed. Often you have the typical speed, which is just what current practices are, and then sometimes you even have required speed where you're trying to match supplier constraints or customer demand. Some people call it tack time in the lean language. We call it required speed, and you can sometimes calculate your required equipment effectiveness. Right? Hopefully a little bit on speed, but again, if you get that booklet, it'll go into a lot of detail about calculating ideal speed, etc.
Great, thank you very much. Okay everyone, that draws our webinar to a close today. I'd like to thank you all for attending. Just a quick reminder to visit our events page on the CTPM website for events happening in capital cities this year. Please feel free to contact us anytime if you have any further questions or require information, or would just like to have a chat. Our next webinar will be held on April 12th, and we'll be looking at getting your operator training and support documentation right. On behalf of everyone here at CTPM, we hope you enjoy the rest of your day. Wishing you all the very best, and we'll see you next time.